This is another equation type that is an exponential. It's an applied problem, so it's an application of exponentials again. This one's dealing with population. We have this particular, we know it's exponential, this particular function, because it has a base of 2 raised to some power with a variable or x or t in it or something like that. So we're wanting to find the population in the city in 2003 and in 2011. A couple of things to keep in mind. This function is for the population in thousands of people. So let's find the first one, and I'm going to explain why that matters. Population in 2003 is when t is 0. So that means that we're looking at the population of 0. So we've got 1,500 times 2 raised to the 0.1046 times 0. Okay, so you probably see this pretty quickly, that this is the same as saying 2 to the 0. Now, another rule of exponentials is that any number like this, any base raised to 0 is always going to be 1. So this is 1,500 times 1, or just 1,500. Now, this is in thousands because of the words that we read just a second ago. Okay, the population in thousands of people of a city is growing according to this function. So when we add 1,000 to this, this is really 1.5 million. Okay. Now, for your answer for my math lab, we're just going to be putting in 1,500, okay, because everything's in thousands. But when we get down to part C, we're going to need to know this information about what the million means, because we're talking about 6 million. Okay. In fact, if we look at this here, 6 million is the same thing as saying 6,000 thousands. And so we'll be using that in just a moment. But for our purposes, let's take a look at what population in 2011 is. So in 2011, we're talking about t is 8. So we're looking at p of 8. And once you work it out, you'll find that, let me put approximately, this is going to be 2,679 thousands. I'm not going to worry about rewriting it here into millions. This is what you'll put in. Let me show you. See, that's what you'll be putting in. Now for the next one, and 2017, you're doing the same thing. You can go ahead and plug that in. It's going to be 4139. Okay, now let's find the year that the population will reach 6 million. So we are looking at that. This is part C. So we're looking when it reaches 6,000. Okay, so to get this exponential by itself, we first are going to get rid of this 1,500. I'm going to divide both sides by 1,500. I get 6,000 divided by 1,500 is 4. and this is equal to 2 to the 0.1046 t. Now, 4 can be written as a base 2, so we're going to do that here. So now that we have the same base of 2, I can let this exponent equal to this exponent. So I have 2 is 0.1046 t, and that means that t is equal to 2 divided by 0.1046. So this is approximately 18.79 ... Okay, so we have between 18 and 19 years that it's going to reach 6 million. So if I add, let's see, if I add 2003, because that was our initial year, to 18, that's going to be 2021. And if I added 19, then that would be 2022. So that would be the following year. I wonder which one it will be. So let's go over to my math lab and see if we can find out. So it says, in the year blank, the population will reach 6 million. Round to the nearest whole number as needed. So I'm thinking, if I look back here at my value, that if I'm rounding to the nearest whole number, you know, technically I would have like 0.79 here. So this would be 0.79. I'm thinking that this is going to be 2022 will be the best answer. So sometimes the wording of the question leads us into what the answer is. So let's try that one. Okay, so that's good. That's what they're looking for, and that helps. A lot of these details are just, you know, the big things are what's important, but these little details about, you know, what the, you know, how to round it, things, it's going to be a big deal on your test, but it's not a big deal overall. As long as you can do the work is really what I'm hoping for here. So that's why I wanted to show you the logic for this. And that's it. Thanks.